The hottest science news of the week has revolved around our sun, which continues to be a source of endless fascination, mystery, and discovery for astronomers and physicists around the world. A series of stunning new studies have shed light on previously unexplained solar phenomena and drawn attention to the dynamic environment surrounding our star. One of the most remarkable breakthroughs concerns a long-standing puzzle: why the sun's outer atmosphere, called the corona, is vastly hotter than the layers beneath it, including the core, where nuclear fusion takes place. For decades, scientists have theorized that magnetic waves, rippling and twisting through the sun's magnetic fields, may carry enormous amounts of energy from the inside of the sun toward its surface. These waves were proposed in the 1940s, but despite numerous attempts, researchers struggled to detect them directly. Now, a groundbreaking study has achieved what generations of solar physicists had hoped for: direct detection of these elusive magnetic waves, confirming that they do indeed transport energy upward and may finally explain the corona's intense heat, which can reach millions of degrees Fahrenheit. This discovery not only solves a major astrophysical mystery, but also deepens our understanding of how stars behave and evolve across the universe. Magnetic fields on the sun are immensely powerful and constantly in motion. They twist, bend, snap, and reconnect, building up tension and releasing it in the form of solar flares and coronal mass ejections. These events send bursts of charged particles flying toward space at incredible speeds, sometimes toward Earth. When these particles interact with Earth's magnetic field, they can create beautiful auroras, but also potentially dangerous geomagnetic storms. Another new study released this week examined the most extreme of these solar superstorms and revealed sobering details about their destructive potential. According to researchers, the next major solar superstorm, which is considered inevitable over long timescales, could cause catastrophic damage to modern technology. Satellites would be among the first casualties, as they are directly exposed to space weather. A sufficiently powerful geomagnetic event could strip satellites of their electronics, knock them offline, or push them into decay orbits. Because so much of modern infrastructure relies on satellites for communication, navigation, and weather forecasting, the consequences could be severe. Scientists emphasize the urgency of preparedness, especially as the sun approaches a period of maximum activity in its 11-year cycle. While the sun has dominated the headlines, another cosmic visitor has captured scientists' attention: Comet 3 I/Atlas, an interstellar comet that is currently making its closest approach to our star. Unlike typical comets that originate in the solar system's distant Oort cloud, Comet Atlas comes from outside our solar system entirely, making it an extremely rare and valuable object for study. As Atlas reached perihelion, the point in its orbit closest to the sun, NASA spacecraft observed the comet undergoing rapid changes. The heat and radiation from the sun caused its icy nucleus to release gas at an accelerated rate, brightening spectacularly and forming an impressive tail. This brightening indicates that the comet's ices, accumulated over billions of years in the frigid void between stars, are now vaporizing in great quantities. The James Webb Space Telescope offered an even more detailed look at the comet's chemistry. JWST's observations revealed that long exposure to interstellar radiation has transformed many of the molecules inside the comet, giving researchers a direct glimpse into the harsh chemical processes that occur outside our solar system. These findings also suggest that Atlas may contain materials altered by cosmic rays in ways never before observed. Scientists expect that in the coming weeks, as two different spacecraft prepare to pass through the comet's tail, even more extraordinary images and data will emerge. Beyond space science, a sensational paleontological discovery has reignited one of the longest-running debates in dinosaur research. For nearly 40 years, scientists have argued about the identity of a small tyrannosaur species known as Nanotyrannus. Some experts believed it represented a separate species, while others insisted it was simply a juvenile form of the mighty Tyrannosaurus rex. The controversy has fueled countless studies, museum exhibits, and scientific disagreements. Now a fossil known as the dueling dinosaurs, unearthed in 2006, but only recently analyzed in full detail, may finally settle the debate. The fossil preserves an extraordinary scene, a triceratops locked in what appears to be mortal combat with a fierce tyrannosaur. The preservation is so complete that researchers were able to study the bones with unprecedented precision. Their findings indicate that the tyrannosaur in the fossil was a fully grown adult and not a juvenile T-Rex, providing strong support for the idea that Nanotyrannus was its own distinct species called Nanotyrannus lancensis. This conclusion has shifted the consensus among paleontologists, many of whom now accept that Nanotyrannus existed as a separate species rather than being a young T-Rex. However, the situation has grown more complicated, as another scientific team has announced the identification of a second species within the genus, named Nanotyrannus lithius. While this new classification expands the Tyrannosaur family tree, it also introduces fresh points of disagreement, leaving some researchers wondering whether the debate is truly over or simply entering a new chapter. As discussions about ancient monsters continued, a surprising study about artificial intelligence and human behavior also grabbed attention. Researchers discovered that chatbots and language models tend to give slightly more accurate responses when users speak to them rudely. The improvement is small, around 4%, but statistically measurable. The study categorized prompts ranging from polite requests to hostile or insulting commands, and found that ruder phrasing sometimes prompted more precise answers. The cause may be related to how large language models interpret urgency or intensity in human language, but the researchers caution against adopting rude behavior as a strategy. Habitual hostility toward machines may spill over into interactions with real people, damaging communication and reinforcing negative habits. Beyond that, the researchers jokingly warn that if AI were ever to gain true sentience, a scenario considered extremely unlikely, users might regret treating it poorly. The study ultimately encourages users to maintain respectful communication, both for the sake of social well-being and to avoid reinforcing negative patterns of speech. On the medical front, concerns have been raised about the future of mRNA-based research in the United States. The introduction of mRNA vaccines during the COVID-19 pandemic was considered one of the most remarkable scientific and technological achievements of the previous Trump administration, enabling rapid development and widespread distribution of life-saving vaccines. These vaccines significantly reduced hospitalizations and deaths, bringing the pandemic under control far faster than many experts had predicted. However, in a surprising turn of events, the current administration's policies have resulted in funding freezes, the cancellation of major research projects and widespread layoffs across federal sectors involved in mRNA development. Many scientists fear that these cuts could undermine years of progress, just as the technology is beginning to show enormous promise for treating cancer, autoimmune disorders, and rare genetic diseases. Because mRNA platforms allow for rapid and customizable treatments, many researchers see them as revolutionary tools that could redefine medicine over the coming decades. Life Science published an in-depth report on the uncertainty now facing the field, highlighting the concerns of scientists who worry that the U.S. may fall behind other nations that continue to invest heavily in mRNA innovation. Adding to the cosmic beauty of the week's discoveries, the James Webb Space Telescope delivered a hauntingly beautiful Halloween-themed image of the Red Spider Nebula. This planetary nebula is located thousands of light years away and showcases the dramatic final stages of a dying star's life. When stars like our Sun exhaust their nuclear fuel, they expand into red giants and then shed their outer layers, creating gigantic shells of gas and dust that glow with heat and radiation. In the case of the Red Spider Nebula, these gas outflows have created long, twisting filaments that resemble the legs of a monstrous cosmic spider. JWST's highly sensitive instruments revealed delicate details within these filaments, showing shimmering strands of molecular hydrogen and chaotic fragmentation caused by the violent outbursts of the star. The result is a breathtaking display of color, texture, and motion frozen in time, offering astronomers a deeper understanding of the processes governing stellar death and rebirth. Throughout the week, these diverse discoveries, from the inner workings of the Sun to the icy chemistry of an interstellar comet, from dinosaur battles preserved in stone to the uncertain future of revolutionary medical technologies, have highlighted the incredible range of scientific research underway today. Each finding adds a new piece to the puzzle of our universe, reminding us how much remains to be explored and how rapidly our understanding continues to evolve.